Hello, we've done our single replacement lab. As you recall, when we talked about chemical reactions, a single replacement reaction is a reaction where one element replaces another. This one element is a single element by himself, and he replaces an element that is a part of a compound. The single replacement lab we saw that magnesium managed to replace copper, and we got copper deposited. Magnesium, in this case, it doesn't appear it replaced anything on the zinc, but we definitely had a reaction. Hello. Thank you, Lori. We definitely had a thank you, Lori. College girls home. We definitely had a reaction with our silver, and we had a reaction with hydrochloric acid. Here you can see a little bit of some kind of deposit on our zinc with our magnesium. A little bit maybe with the aluminum. We kind of were up in the air. This is from 6th hour. The other one was from 7th hour. But I digress. So, this, in your notebook, you have a sheet called Hot or Not. And that is the activity series for metals, which also on the back of your periodic table. And this tells us what order things should replace in. And if you notice, I've highlighted the elements that we used in the lab. Magnesium, aluminum, zinc, hydrogen, copper, and silver were all different cations in the lab. And we found magnesium to be the most reactive, and we found silver to be the least reactive. But notice our aluminum. Aluminum should have been second, and it wasn't. And I know I discussed this in at least one of the classes. Aluminum coats over with an oxidation level very quickly. So it makes aluminum oxide and coats the surface, and that's probably why we didn't get a very good reaction. Okay? It should have been more reactive than the zinc, less reactive than the magnesium. Notice I also have on here an activity series for the halogens. The fluorine is the most reactive halogen. Iodine is the least reactive. Just like a metal can replace another metal, or it can replace hydrogen since it's a cation, a nonmetal can replace another nonmetal. All right, go ahead and get page 12 out in your or in your note packet, and we're going to do some of these together. We're basically going to take the beginnings of reactions and try to decide if they will happen or not. If the single element is more reactive than the cation or anion, if we have halogens, which one's more reactive? If the single is more reactive, then the reaction will occur. Okay? So we start with magnesium and copper. Magnesium way more reactive than copper, so the magnesium will come in and replace the copper, and we will have magnesium sulfate and then copper solid. This here is copper 2 solid, or copper 2 sulfate, but it doesn't matter. Copper is just copper when it's a solid. Next one, aluminum and hydrogen. Aluminum will come in and replace the hydrogen. It is to the left of the hydrogen. So aluminum will become aluminum sulfate. Now stop and think about how you're going to write that. Sulfur has a -2 charge. Aluminum has a +3 charge. So we'll need 2 aluminums, 3 sulfates. And then we'll have hydrogen gas evolved. Next one, we have potassium iodide and chlorine gas. So this time, instead of looking at metals, now we're looking at, that's not going to work. Now we're looking at our halogens. Iodine is to the right of chlorine, so this reaction will not happen. If the reaction won't happen, we write no reaction. Next one, copper and iron. If we look at our series up here, here's iron, copper is to the right, so again, that reaction will not happen. Lithium and hydrogen. Lithium is well to the left of hydrogen, So that reaction will happen. The lithium will replace the hydrogen. Now, actually, you would think, all right, it's going to replace the hydrogen, we'll get lithium oxide. But actually, what it does is it just replaces one of the hydrogens and creates lithium hydroxide. That's not something I would expect you guys to know. I'm just something that, knowing it, I can't write it the wrong way. And hydrogen gas. Next, calcium iodide and bromine. Back up to the top. Bromine is to the left of iodide. Bromine here, even though it's on the right-hand side, it's the single element. It's more reactive than iodine. So yes, it will replace the iodine. Calcium bromide plus iodine. And iodine, in this case, is going to be a solid. Bromine will be a liquid. And how do I know that? The periodic table that you have has their phases based on the color of the lettering on the periodic table. Next one, magnesium chloride and iron. Magnesium's to the left of iron, so therefore the magnesium will replace it. We'll get iron chloride and magnesium. Anybody notice a problem yet? That's right. Iron could be iron 2 chloride, or it could be iron 3 chloride. We don't know. So you can write it either way. If you choose to make it iron 2 chloride, you would write FeCl2. If you decided that you want it to be iron 3 chloride, it would be FeCl3. That's up to you. It's your choice. Zinc and copper. Zinc, more reactive than copper. So zinc will bond with the nitrate. Nitrate has a -1 charge, so we need 2 of them. And copper. Next one, aluminum and iron. Aluminum, in this case, is to the left of iron, even though we found it to not be very reactive. Aluminum, of course, has a +3 charge. Oxygen has a -2, so we're going to need 3 oxygens and 2 aluminums, and we would have elemental iron deposited. Our last one on this practice page is iodine and bromine. The iodine is to the right of the bromine, or well, the iodine on the scale up here is to the right of the bromine. So iodine is less reactive, so this guy will not happen. All right, so I've got another worksheet for you that you will do in class to practice this, and there you go. Thank you very much.